All right, hi guys. So today's video is going to be some examples of Coulombic attraction, atomic radius, and then ionization energy and electronegativity. All right. So these are some real life examples that I would normally do in the classroom, but since we're not in the classroom, you get to see me do them in my living room. All right. So the first one that I'm going to explain is the relationship between Coulombic attraction and atomic radius. All right. So Coulombic attraction is that pull between those protons and those electrons. All right, so it's that pull between the two of them, okay? And Coulombic attraction, all right, has a couple things that's going to affect it. How close the protons and the electrons are and how many there are, okay? So atomic radius, I think the best way to kind of explain it is kind of like they're putting on layers, okay? So if I was an element in the first ring, okay, I would have one layer, okay? So if I had my cell phone, my electron in my pocket, and I was the proton, okay? If I put my cell phone in my pocket, all right, and it vibrates, all right, there's a very, very close connection between the protons and the electrons, my cell phone and me, meaning that it's gonna be a really strong vibration, just like it's gonna be a really strong Coulombic attraction, okay? So like lithium, who only has two rings, or hydrogen, who only has one ring, okay, that Coulombic attraction is going to be really, really strong, because just like my cell phone's really, really close to me, I can feel that strong vibration. So can the protons and the electrons, okay? But as we go down the periodic table, all right, they put on more orbitals because more electrons need to find a home, okay? So now I have one ring, two rings, all right? I can still feel my cell phone vibrate, okay? They're still gonna have that Coulombic attraction, but it's gonna be a lot weaker, okay? So my atomic radius has increased, I'm larger, okay? But that Coulombic attraction is weaker because now my cell phone's further away from me, all right? So its vibration's gonna be weaker, okay? And you could think of this as you go down the whole periodic table. So if I put on my final jacket, which I probably should have put on earlier because it's a little small, okay? All right, I'm a lot bigger, okay? My atomic radius has clearly increased. I look like the kid from A Christmas Story. Okay, my atomic radius has clearly increased, okay? My cell phone now is gonna be a lot further from the inside of my first jacket, okay? So my atomic radius has increased, okay? But my Coulombic attraction has decreased, because now I could barely feel my cell phone vibrate, okay? So that relationship, all right, so atomic radius has increased, I am larger, okay? But Coulombic attraction has decreased because, all right, it's harder for me, just like it's harder for me to feel my cell phone vibrate, it's harder for the protons and the electrons to feel that pull because they're further away from each other, okay? So that's the first example of atomic radius. Okay, I'm gonna take off my winter coats. The next one that we're gonna look at is ionization energy, okay? So ionization energy is that ability to steal an electron from an atom, okay? So that has a relationship with Coulombic attraction and atomic radius as well. They kind of all interweave with each other, okay? So again, summarization, Coulombic attraction is very large, it means our atomic radius is very small. If our atomic radius is very large, it means that our Coulombic attraction is very weak, okay? So ionization energy is the ability to steal an electron from an atom, okay? So I'm gonna use a marble, all right? It's very YouTuber of me. And that's gonna represent my electron, okay? So if I'm an atom, I'm still a proton, okay? And I have my electrons very close to me, all right? I have a pretty strong hold on my electron, okay? It's close to me, my atomic radius is really small, so my Coulombic attraction is very large, okay? It's gonna be really hard to take this marble from me, okay? Because, again, atomic radius is really small, my Coulombic attraction is really large, there's a really hard grip on this, I'm holding on to this marble for dear life, okay? If someone were to come and try to take it, it would require a lot of energy. I would put up a really good fight because it's really, really close to me, okay? So because it's so close to me, my Coulombic attraction is so high, my ionization energy is going to be really, really high as well, okay? So where Coulombic attraction and atomic radius are the opposite, Coulombic attraction and ionization energy are the same, okay? So the stronger my Coulombic attraction, the higher my ionization energy, okay? So this would affect, okay, I'm going to make my radius larger, so my Coulombic attraction has decreased, okay? And I'm going to loosen my grip because it's further from me, okay? So now if I had someone come, got a large atomic radius, my Coulombic attraction is weaker, that's why I opened my hand, all right? So now if I had someone to come and take my marble, it would be really, really easy for them because I have a really, really low ionization energy because, all right, I'm further away from my nucleus, meaning that my protons have a less of a hold on my electrons. Okay, so again, ionization energy, okay, it does have a relationship between atomic radius and Coulombic attraction, okay? So my radius, I'm gonna make it really small. My Coulombic attraction is really high, tight grip, okay? My ionization energy is gonna be really high because it's gonna be really hard to take the marble from me, all right? But if I make my atomic radius large, bloop, my Coulombic attraction becomes weak, bloop. It's now a lot easier to come and take that marble, okay? So, in summary, Coulombic attraction, if it is large, our ionization energy is large. If our Coulombic attraction is weak, our ionization energy is weak, okay? And a similar principle happens with ionization energy, okay? The only difference is, all right, so hand sanitizer, stay safe, okay? So the only difference is we're gonna split me in half. One element has a strong hold on this electron. The other element also has a hold on this electron, okay? So again, it's gonna be that relationship of, okay, if I have a strong Coulombic attraction, it's gonna pull that electron, okay? If I have a weak Coulombic attraction, it's not really gonna pull that electron, okay? So ionization energy and electronegativity have the same kind of trend where the stronger the pull on the electron, because of Coulombic attraction, the stronger the energy, okay? The weaker the pull on the electron, the weaker the ionization energy or electronegativity. Okay. So guys, we're gonna be going over this more this week, but I wanted to give these examples because normally I give them in class. So hopefully they helped make some connections in your brain. If not, we're gonna keep going over it, but you could always ask questions. I hope you guys have a great rest of your day.